Well, first of all, what the first message that I have is that unfortunately Wes just did my presentation. He did a really good job at presenting the same topic that I'm going to talk about, which is great. Thank you guys for being here. Like Scott mentioned, I work at PrecisionHawk. For the few people that hopefully don't know about PrecisionHawk, we're actually based 15 minutes from here. And we specialize in precision agricultural drones, UAVs. So that is actually a picture of our fourth generation of UAV called the Lancaster. So like Todd actually explained in the first segment of this, one of the most difficult obstacles that we're facing as population grows is to be able to feed everyone, right? So we need to be able to find a system that is feasible and efficient. That's what we're looking for. As technology increases, evolves, we should be able to integrate that technology into creating some type of sustainable system to be able to feed everyone, right? So we have built our system, our business, around empowering users. It is very nice to be able to know that Monsanto is using algorithms to be able to increase efficiency. It is very nice to know that obviously universities are working on research, but I believe that the most important effort that we're making on UAVs, not just PrecisionHawk, but in general, anyone that specializes in precision agriculture, is to be able to empower users, individual users, farmers, right? So what we do, we actually develop a system, a complete end-to-end system that allows any farmer to be able to operate our system, to be able to upload information, get the raw data, images, and be able to get to a solution, to some type of information that they're looking at to be able to control their inputs on their farm. That's what we're looking at. So how farmers will benefit? Obviously, UAV technology is very new, but it actually allows, just like Wes was explaining, to be able to monitor things almost on an instant. The fact that it took you 3 months to get your results back 12 years ago, and now I can give you results from a field that I just flew within 2 hours, really speaks volumes about how quickly this technology is really changing the industry. It is a industry-changing technology, and it allows people to obviously optimize inputs, react quickly to threats, and be able to save time with crop scouting, like Wes was talking about, to be able to autonomously be able to monitor the actual potential yield of your crop throughout the season. So I spoke about end-to-end solution. So we capture data, we manage the data, we create insight to that data, and we actually create some type of output. We'll talk about specific outputs in a bit. The most important thing, and actually was, you mentioned this again, is be able to capture information and compare it in chronological aspects, not just throughout the season, but multiple years in a row, to see how you're actually improving your efficiency, how you're improving your methods, and also by having that information in hand allows you to make decisions even quicker, right? So that's probably the most valuable aspect to what we do. So the key differences from what the market looks like as a standard and what we've actually been able to do. So on the, which one is the laser? That one, okay. So on the left here, we see the market standard of what a orthomosaic looks like, and actually a multispectral image, compared to what we have actually developed. I have an answer for you. Right now, we are able to get, with our high resolution sensors, sub 1 centimeter, so per pixel. So that's pretty good. So it actually allows you to see each leaves. So that's game changer, right? That's a complete game changer. On the right, we actually have developed something that we call an algorithm marketplace. So prior to really 10 years ago, if you wanted to get to some type of result, you would have to resource somebody that specializes in GIS, an agronomist, or somebody that knows the area, the environment very well. If you're a farmer and you want to be able to have the same tools that large enterprises and corporations have to be able to improve efficiency, we needed to create a tool that allows people, just like you buy apps at the App Store, to be able to choose the application that you want and just care about getting that result. You don't have to worry about what's in between. We take care of that. So that's what we've developed. It's a very simple solution to emerging need that most farmers need right now, especially I would say in North America most of the time, but as developing countries are actually becoming more efficient in their agriculture, it is a worldwide solution. Okay, so this is a bigger picture. Key difference. So on the left, we see what the market standard looks like. And on the right, we actually is a result. It is a much richer, and probably the most important thing is that you can actually get a better detail on the specifics. And this is just the base. So the orthomosaic is the first result that you get from collecting hundreds of images over a field. So like Wes was explaining, you, instead of manually flying, we actually do everything is autonomous. And you launch the plane, and I actually make this movement because that's how you throw our plane. You launch the plane, the aircraft just does it on its own and is able to plot the whole field. What the orthomosaic does is it actually integrates those hundreds of images into a rich image that you can either read it as a 2D or 3D. And based on that, you can actually run any of the algorithms. So, for example, one of them that probably pertains to this subject specific is be able to count the plants. And this is actually one of the most essential tools that we have for the beginning of the season. To be able to count how many seedlings you have probably within a month after you've planted, that is essential for the efficiency and the yield, actually, the end yield of any farm. So that is one of many tools that we have right now. This actually gives you a really good image on what we're capable of doing. So one of the reasons why we've actually spent so much time and effort into creating this algorithm marketplace is the ability to actually layer different parts of different information. So whether you're getting information from high resolution visual to multispectral, to hyperspectral, to LiDAR, whichever it might be, you're able to integrate all that information into creating one map of your farm, of your crop, that will give you all the information that you need as far as the health, the vigor, and the potential yield, whether you're talking about biomass, canopy cover, whatever it might be. This is probably the way we categorize, and it really varies depending on the environment and the type of crop, the different options that you have for the algorithms that we've developed. In the spring, we are able to run just a bare earth, which is pretty much just the orthomosaic, to weed mapping, plant counting, spacing, Usavi, scout view, all that stuff. This is specifically speaking, especially in this area, targets are corn and soy. So this would specifically target corn and soy depending on the season and the time of the crop. So to wrap this up, this is a very new technology, and probably the biggest restriction that we have currently is actually the regulations, because the FAA, the government, is still trying to figure out how they're going to regulate the use of UAVs. Currently, right now, in order for any commercial entity to be able to use a UAV, the operator must be a licensed pilot. That is the restriction so far. Yes, and that's the reason why I actually work at PrecisionHawk when I started there, is because I am a pilot. But that is the restriction as it stands right now. We actually work very closely with the FAA. Currently, we're actually doing some testing to increase that usability, and things could potentially change in the next few years. I can probably tell you that things are gonna change quicker abroad than here in the United States, but most likely that will change as time comes and as the industry actually puts pressure on the government and specifically the FAA to change the regulations. Specifically to agriculture, I would say the vast majority of commercial purpose UAVs are actually tailored to agriculture because of this need that we have as a population of any country, a global population, is to be able to increase efficiency and yield in the type of crops that we grow. So that's all I have. Thank you very much.